In this next unit, we're going to take a look at reasoning with angles and triangles, which is a fancy way of saying we're going to look at how trigonometry works combined with our math reasoning and our logical reasoning that we did in the last unit. So, in this unit, we're going to use inductive reasoning and deductive reasoning to determine the relationships between pairs of angles formed by transversals and parallel lines, and we're also going to determine the properties of angles in triangles and in polygons, so two-dimensional shapes. So, for the first part, we're going to say for the types of angles, well, draw an appropriate arc to represent angle x in each case. For a figure which represents a right angle, use that right angle symbol. So if we're talking about an acute angle between 0 and 90 degrees, that's just going to be this angle in here. A right angle is going to be that 90 degrees here. A obtuse angle is going to be one that's going to be between 90 and 180. A straight angle just looks like a line, and that's one that's rotated for a full 180 degrees if we pick a rotation starting point in here. If we talk about a reflex angle, well, that would be like the outside of either a obtuse angle. So if I look at it here, this one is going to be the same as the one here or the one in here. So that would be the outside of an obtuse angle or a acute angle. And if we talk about a complete rotation, that would be like if I started at the end point here and I'm rotating all the way around to get back to the starting point again. If we're looking at angles on one side of a straight line, well, you might not have a protractor at home, so I'm just going to tell you what the angles are here. So the angle of x is going to be 140 degrees. The angle of y is going to be 40 degrees. And they're going to combine to make 180 degrees. If I look at example B, angle A is 120 degrees, angle B is 60 degrees, and they add up to 180 degrees. If I'm looking at P, Q, and R, P is 35 degrees, Q is 90 degrees, and R is 55 degrees. And when I add all three of them up, I get 180 degrees. So if I'm using inductive reasoning, angles on one side of the straight line always add up to 180. The angles on one side of a straight line are always going to add up to the total angles that exist in, like example D of the first part, a straight line. Now, in terms of important terminology, we call these supplementary angles. Supplementary angles, which supplement each other, are always going to add up to 180 degrees. So anytime that we talk about straight lines or angles that up to 180 degrees, we call them supplementary. So if I know that two angles that exist on a straight line have to add up to 180, then that means that if I'm trying to find an angle on a straight line, I'm just going to say that 8 degrees is going to be 180 minus 155, which means that this one is going to be 35 degrees. If I'm trying to solve for B, all three of these have to add up to 180, which means that B degrees is going to equal 180, and then I take away the 51 degrees, and I take away the 68 degrees, which means that it's going to be equal to 61 degrees. Now, if I am looking at C, for C, these two are on the same line, which means that C degrees has to equal 180 minus 80. C has to be 100 degrees. But I can continue this pattern all the way around. If I know that C is 180 degrees, or sorry, 100 degrees, and C and E create a straight line, then I'm going to say that E degrees is going to equal 180 minus C degrees, which is 100, and that one's going to have to equal 80 degrees. And I can see that on the bottom side here, the 80 and the D degrees makes up a straight line, so D degrees has to equal 180 minus 80 degrees, or 100 degrees. So, this last example is representing pulling from our supplementary angles going all the way around one point. Our next concept, we call it opposite angles at a vertex, or we can also refer to it as vertically opposite angles. Each one makes sense. So, straight lines which cross and make an X shape, the point where the two lines cross or intersect is called a vertex. So that would be this point right in the center here. In the diagram, P and Q are going to be opposite at a vertex because P and Q are on opposite sides of that vertex point. At the same rate, R and S are at opposite sides of that point. We call those vertically opposite angles. In the last case, we can see that if I look here, the two opposite sides had the same angle, and these two opposite sides had the same angle. Which means that if the opposite sides of a vertex always have the same angle, so in this case A and B should be the same, S and T should be the same, or C and D are the same, and U and V are the same, if I'm using a protractor to actually measure this out, I can verify this. So in this case, A is 110, and B is 110. C is 70, and D is 70. And this one actually works if you use a protractor to check it. In the second case, S is 35, T is 35. U is 145, V is 145. Which means that the opposite angles at a vertex are always going to be equal. And we typically refer to it as vertically opposite angles. The word vertically in the vertex has nothing to do with actually being vertical. When we call it vertically opposite, vertically means at the vertex. So don't think of it as up and down, think of it as at the vertex when referring to these ones. Alright, if I have the angles going around a point, well, I'm just going to give you these angles again. E is 110, F is 110, and G is 140. When I combine all of them, I'm going to get 360 degrees. M is 80 degrees, N is 78 degrees, and P is 112 degrees, Q is 90 degrees. Add all four of them up and I get 360 degrees. So a conjecture that can be made on angles around the points is they all add up to 360 degrees, which makes sense because if I start at 1 and go all the way around, I'm just making one big circle, which we already know adds up to 360 degrees. If I know that's true, then if I have all the other points and I just want to find one missing point, then I can solve it for around a circle. I can say that A degrees is going to be, well, if they all add up to 360, I'm going to take away the 52, take away the 57, take away the 71, and take away the 80, and A is just going to be what is left. In this case, A is going to equal 100 degrees. In the second case, I have two missing values, B and C. But when I take a look at it, I can combine two of the concepts that we've already taken a look at. I can say, well, for C, the 60, the 55, and C all make a straight line. So I can use my supplementary angle rules to solve for what C would be. I'm going to say that C degrees is going to equal 180 minus 60 minus 55. And I can say that C is going to add up to 65 degrees. I can say for B, that if that's 65, 360 minus 120 minus 60 minus 55 minus 65 is going to leave me with B, which is 60 degrees. We can also see for B that if this is a straight line and this is a straight line, then the center point is going to be my vertex, and the 60 and B are vertically opposite, which is the reason why they are going to be equal. Alright, if I'm looking at the sum of angles inside of a triangle, well, in this case, we have a triangle that's built on this diagram. And what they've done is they have cut off angle 1, they've cut off angle 2, and they've cut off angle 3. And they just arranged all three of these smaller triangles and put them side by side with the acute angle touching for all of them, and discovered that when I arrange them, it makes a straight line, which means that all of the angles inside of a triangle have to be supplementary or add up to 180 degrees, which most of us already knew.